In this lesson, we are going to look at how to balance redox equations in acidic solution. In order to balance redox equations in acidic solution, we must follow these 7 general steps. You must memorize these general steps. In this lesson, we're balancing in acidic solution. In the next lesson, we're going to balance in basic solution, and one of them always appears on the public exam. So this material you really need to know. So again, you need to memorize the general steps. The more practice you do, the easier they'll be, and you may not need to memorize them, you may just remember them from the practice alone. When given an equation to balance an acidic solution, you must first write the half reactions without including the electrons. Break them up according to their elements, but do not include the electrons yet. Then you must balance for all atoms other than oxygen and hydrogen. We're going to balance those in a different way in the next 2 steps. So again, look for all atoms other than oxygen and hydrogen and add coefficients if it needs to be balanced. Then you balance the oxygen atoms by adding water to the opposite side. You balance the hydrogens by adding H positive to the other side. And it's at this point that you balance for the charge by adding electrons. Then you must make sure that the number of electrons lost equals the number of electrons gained, and you may need to multiply the entire half reaction by a number, and then you can finally add them to get the overall equation. Now these are the general steps. It may seem a little bit daunting right now, but we will go through several examples where you'll see that their steps repeat over and over again, and as long as you keep with those general steps, you will not get the question incorrect. So let's go through the example that's already done out for you. We've been asked to balance this equation in acidic solution. So step number 1, we need to divide them up into their 2 half reactions. Chromium and chromium goes together, iron and iron will go together. That's step number 1. Step number 2, you need to balance for all atoms other than oxygen and hydrogen. If we look, we have 2 chromiums on the reactant side, only 1 on the product side, so we need to put a 2 in front of that chromium. We have 1 iron and 1 iron, so that stays the same in step number 2. In step number 3, we need to balance for the oxygens by adding water to the opposite side. If I look at the first half reaction, you should notice that I have 7 oxygens on the reactant side. Therefore, I need to add 7 waters to the opposite side. So then I have 7 oxygens and 7 oxygens. That's balanced out. There's no oxygens in the second half reaction, so I don't need to worry about that one. Then we need to balance for the hydrogens by adding H positive to the opposite side. I don't have any hydrogens on the reactant side, but notice that I have 14 on the product side, 7 times 2. Therefore, I need to add 14 H positive to the other side. There are no hydrogens in the second half reaction, so we don't need to worry about that. Then we need to balance for the charge. And this is usually the step where students start to make mistakes. I want to ask you, on this reactant side, what is the overall charge? I want you to think about it for a second and try to calculate. What is the overall charge? Let's see if you'll make a mistake or not. The overall charge on the reactant side is 12 positive, or positive 12. Hopefully you got that correct, but I'll explain if not. And don't worry if you didn't, it's your first time trying it out. We have 14 positives right here, and we have 2 negative there. 14 positive, subtract 2, gives us 12 positive on the reactant side. Now try that again on the product side. What is the overall charge here on the product side? Hopefully you got 6 positive, or plus 6. 2 times 3 plus 0 gives us 6 positive. Now just like we were doing in the last lesson, we always add electrons to the higher number. So you're going to have to add electrons here to the reactant side. How many electrons are we going to add? Well, how many do we need to add to 12 in order to get 6? That should be 6. Perfect. Done. Let's do it on the second half reaction. The overall charge here on the reactant side is 2 positive. The overall charge on the product side is 3 positive. We'll add electrons to the side with the larger number. How many do we need to add to 3 to get 2? We need to add 1. We've added the electrons, so we have our 2 half reactions. The next step is we need to make sure that the number of electrons gained equals the number of electrons lost. And by what I have circled here, we have 6 electrons gained, only 1 lost. In order to make that equal, we need to take the second half reaction, and we're going to need to multiply that by 6. As we can see, sure enough, we have to multiply by 6, but we need to multiply the entire thing by 6. So we get 6 Fe2 positive plus 6 Fe3 positive and 6 electrons. Now the number of electrons gained equals the number of electrons lost, and that can in fact be cancelled out. Is there anything else that we can cancel? No, there's not. So we can write the overall reaction. At this time, I want you to pause the video and I want you to attempt example number 2. Follow through with the 7 steps, see how far you can get before you get stuck. If you can do the entire question by yourself, fantastic. You can move on to the next lesson. Otherwise, I will go through example 2 and example number 3. So again, pause the video, try example number 2. Step number 1. Write out the 2 half reactions. So we have MnO4 negative goes to Mn2 positive. For the sake of both of our sanities with respect to having to write this out on an iPad, I'm going to eliminate the states of matter, but you are expected to keep them in. And H2C2O4 goes to CO2. Step number 1 complete. Step number 2, we need to balance for all atoms other than oxygen and hydrogen. We have 1 Mn in MnO4. We have 1 Mn on the product side. That's balanced. We have 2 carbons here on the reactant side, only 1 on the product side, so I need to put it 2 out in front there. And step number 2 is complete. Step number 3 is to balance for the oxygens by adding water. We have MnO4, so we have 4 oxygens on the reactant side. So I need to add 4 waters to the product side. We have 4 oxygens on the reactant side, but we have 2 times 2 or 4 oxygens on the product side, so that's already balanced itself out. The next step is to balance for the hydrogens by adding H positive. We have 4 times 2 or 8 hydrogens here on the product side, so I need to add 8 hydrogens on the reactant side. In the second half reaction, I have 2 hydrogens on the reactant side, so I need to add 2 H positive on the product side. That one is done. Now we need to balance for the electrons. So now you have to look at the first half reaction and determine the overall charge in the first half reaction. And if we look at the overall charge in the first half reaction, we have 8 positive and 1 negative makes 7 positive. And on the product side, we only have Mn2 positive, so it's 2 positive on the product side. We always add electrons to the higher number, so we're going to add electrons on the reactant side. How many do we need to add to get 7 down to 2? We need to add 5 electrons. We do the exact same thing now for the second half reaction. We have an overall charge of 0 here on the reactant side, and we have an overall charge of 2 positive on the product side. We add electrons to the higher numbers, so we're going to have to add them to the products. How many electrons do we need to add to 2 to get down to 0? Well, we need to add 2 to that. And we've now assigned our electrons. Now we have to ask ourselves, is the number of electrons lost equal to the number of electrons gained? Well, we have 5 electrons gained, only 2 lost. So I need to multiply the top one by 2, and I need to multiply the bottom one by 5 in order to make that happen. When you do that, you need to write out the two half reactions in its entirety. We have 10 electrons plus 16H positive plus 2MnO4 negative goes to 2Mn2 positive and 8H2O. And we have 5H2C2O4 goes to 10CO2 plus 10H positive plus 10 electrons. Now we have to ask ourselves, well, what can we cross out? What is identical, or what can we simplify from the reactant side to the product side? We'll always cross out the number of electrons. That was the entire purpose of multiplying the two half reactions by 2 and 5. But there are other things that we can also simplify. I can get rid of all 10 of these H positives, and that will leave me with 6 up here. And that would be the only thing at this point that I can simplify. So I'll write my final answer. I have 6H positive plus 2MnO4 negative plus 5H2C2O4. It does not matter what order you write that in, as long as 3 of them appear in some order on the reactant side. And that goes to 2Mn2 positive plus 10CO2 plus 8H2O. And thinking back to the acids and bases chapter, how do you know that you've balanced this in acidic solution? What ion or compound is there that's screaming acid to you? And that should be very evident in the 6H positive. So I know that this is actually an acidic solution. At this point, give example number 3 a try. Again, we need to balance this equation in acidic solution. Step number 1, break them up according to their half reactions. MnO4 negative goes to Mn2 positive, and H2SO3 goes to SO4, 2 negative. Now we need to balance for all atoms other than oxygen and hydrogen. We have 1Mn and 1Mn as the reactants and products in the first half reaction, 1S and 1S as the reactant and product in the second half reaction, so there's nothing to do for step number 2. Step number 3 is to balance for the oxygens by adding water. We have 4 oxygens on the reactant side, so we have to add 4 waters on the product side. We have 3 oxygens on the reactant side, 4 on the product side, so I need to add 1 more water on this side to give me 4 in total. Now we have to balance for the hydrogens by adding H positive. I have 8 hydrogens on the product side, so I'm going to add 8 H positive to the reactant side. I have 2 hydrogens and 2 hydrogens to make 4 in total on the reactant side, so I need to add 4 H positive on the product side. Now I need to balance for the electrons. Look at the first half reaction. What is the total charge of the reactants in the first half reaction? Well, we have 8 positive and a negative. That makes 7 positive in total. On the product side, I have 2 positive, so we've seen this in the last example. We always add electrons to the larger number. How many to 7 to make 2? Well, we need to add 5 electrons. Let's do the same thing for the second half reaction. We have an overall charge of 0 here on the reactant side. We have a total of 2 positive here on the product side. We always add electrons to the higher number, so we need to add 2 electrons here. Now we need to make sure that the total number of electrons gained equals the total number of electrons lost, which is not the case. So I'm going to multiply the top one by 2 and the bottom one by 5. You need to rewrite that out again. 10 electrons plus 16 H positive plus 2 MnO4 negative goes to 2 Mn2 positive plus 8 H2O. And we have 5 H2O plus 5 H2SO3 goes to 5 SO4, 2 negative, plus 20 H positive and 10 electrons. Now let's see what we can cancel out or simplify. The 10 electrons will be eliminated. The 16 H positive can cancel out 16 of the 20 and leave us with 4 hydrogens on that side. And the 5 waters can cancel out to leave us with 3. Once everything's been cancelled, we can now write out the overall reaction. 2 MnO4 negative plus 5 H2SO3 goes to 2 Mn2 positive plus 5 SO4 2 negative plus 3 H2O plus 4 H positive. We know that we've balanced this in acidic solution because we're left with H positive. At this point, you can now do the balancing in acidic solution questions on the worksheet.